All right, today we are doing 1-1 in pre-calc functions. Today's date is today. Our objective, we're going to identify and evaluate functions and state their domain. First thing I want to talk about is interval notation, which is really not that difficult. Before, whenever we've had an inequality, we've typically done it like that. 0 is less than or equal to x is less than 4. And then if I were to graph it, we're going to have a closed dot at 0 because 0 is part of the solution. We'll shade in between 0 and 4 because that's also part of the solution. And then we'll have an open dot at 4. 4 is technically not part of the solution. There's a different way that we can write this, and it's actually a pretty quick way to do it. Right here, we're going to use a bracket for 0 because 0 is part of the solution, and a comma, and then a 4, and then a parenthesis. We use the parentheses for the open dots. This is called interval notation, and I'll kind of go back and forth sometimes between interval notation and showing it as an inequality. You'll see interval notation a lot on standardized tests, so you need to be familiar with it. That is not an ordered pair. It just means your solution is from 0 to 4 and includes 0. However, sometimes you have something only going in one direction, like x is greater than -1. Well, it's starting at -1 and going to infinity. We're going to use parentheses on both sides here because it's an open dot at -1, and you can never quite get to infinity, so that's why it's a parenthesis again. So again, this is interval notation. Sometimes you have to know whether or not something is a function. It is going to be a function if it passes the vertical line test. This is something from Algebra 1, so I'm not going to spend a lot of time on it. This example up top, not a function because it would not pass the vertical line test. Oh, that's a horrible line. Let's try that again. It's going to touch in multiple spots. This bottom one is a function because no matter where I move that vertical line, it's only touching in one spot. All right. This is function notation. If you have f of 2, and they give you the function f of x equals 4x minus 2 all over x squared minus 2. That does not mean f times 2. Okay? F of x is just a very fancy way of saying y. So f of 2 is saying what is your output when your input is 2. And all you're going to do is make a substitution. You're going to take out that x, and you're going to put 2 in its spot. So you take out that x, and you're going to get 4 times 2 minus 2 on top, which is 8 minus 2, or 6. On the bottom, you get 2 squared minus 2, which is 4 minus 2, or 2. Simplify it all the way, and you get 3. So f of 2 is 3. So when my input is 2, my output is 3. That's also the same as an ordered pair. When x is 2, y is 3. On this one, it's a little bit different because our input is a plus 1. Well, you do the same thing. Wherever you see an x, you just put in a plus 1. So g of a plus 1 equals a plus 1 quantity squared minus 2 times a plus 1 plus 1. On this one, remember a plus 1 quantity squared is not a squared plus 1. You actually have to FOIL that out. Take the quantity a plus 1 times a plus 1 and FOIL. So right here, you're going to have to FOIL. And when you do that, you're going to get a squared plus 2a plus 1. That's the FOILing. And then here you're going to distribute minus 2a minus 2, make sure you distribute that negative sign, plus 1. Then when you're done, you're just going to do your like terms. Your 2a and negative 2a cancels. 1 minus 2 plus 1 is going to cancel, and you're left with just a squared. All right, domain. Domain is your input. What is x allowed to be? Well, we've got a couple scenarios here. On this first one, we have a fraction. We are never allowed to have 0 in the denominator. So you look at that denominator, and x plus 2 cannot equal 0. So in this case, x cannot equal negative 2. So x can be any number except for negative 2. On number 2, again, we have a fraction. We look at that denominator. X cannot equal negative 2 or positive 3. You just take each one of those, set them equal to 0. On number 3, you look at that denominator. X squared plus 1 cannot equal 0. You get x squared. Make that x look a little better. Cannot equal negative 1. Well, I'm never going to square a number and get a negative. So in this case, my domain is all real numbers. Number 4 is slightly different because I have a radical. There's no denominator here. It's a radical. And to take a square root, I know I have to have a positive number. So x minus 1 has to be greater than or equal to 0. I can have 0 underneath that radical. I can't have anything bigger or smaller than 0. I can't have a negative. Everything has to be bigger. So on that one, my answer is going to be x is greater than or equal to 1. And that is my solution. All right. Hope you enjoyed.